Hello. Today we're going to take a simple look at how computers work. We're going to go over an overview. We're going to look at the ultimate computer. We'll discuss the different parts of a computer, and then we're going to wrap it all up. So there are people out there in this world who think computers work by magic. They don't want anything to do with them. They don't understand them, and they don't want to understand them. However, there is a ultimate computer on this planet, and that is a computer that was made by God. And it happens to be us, humans. Our brain has a central processing unit. It has a hard drive for long-term memory. It has RAM for short-term memory. It has the ability to process multiple pieces of information at the same time and handle extremely complex calculations. It has a central nervous system, which is a central network that connects the CPU with the input and output peripherals. We have a 3D bioptic camera that can recognize millions of colors and perform facial recognition. It has speakers. It has a stereo microphone. It has a mass spectrometer that can recognize gases by smell. It can easily, sometimes, communicate with other computers. It has a built-in standard color printer, and it can print in 3D. Of course, if you put garbage in a computer, you're going to get garbage out. This is a common metaphor in computer programming. Garbage in, garbage out. Of course, all this sounds like science fiction. But no matter how hard and close that humans can achieve artificial intelligence, we will never be able to replicate what God has created. So it all starts with a central processing unit, which is made of millions of transistors. It has a machine language that knows how to process all the instructions that come through it. It has a little bit of really fast RAM known as L1 cache on board the CPU. It tells the other components what to do. Modern computers are 64-bit machines and can perform millions of operations in seconds. The CPU is the cerebral cortex of a computer. So, newer computers use 64-bit arithmetic or logic. In other words, they handle 64 bits of information at one time, which allows for integers from negative 2 to the 63rd power to 2 to the 63rd minus 1. That's a pretty long range. So what's a bit? A bit is the smallest piece of information a computer can handle. It's literally a 1 or a 0. It is the foundation of the binary language. In most programming languages, a bit equates to true or false. The bit has its foundations in the transistor. Transistor is made up of three parts: two conductors and two semiconductors. The semiconductor becomes a conductor only when enough current passes through it. When enough current passes through the semiconductor, it goes to the collector, and it results in a value of 1. If there isn't enough current so that it can pass through the semiconductor, the current flows to the base and produces a 0. And hence, this is how we get our binary system. Binary as in two states. So the CPU has to get its instructions from somewhere. So a lot of the data, a lot of the files, as you know, live on our hard drives. Well, when you open a command or you tell the computer to open something, the CPU tells the hard drive, I want this data. The computer transfers that data to the RAM. The data and instructions are then stored in memory blocks in the RAM until it is no longer needed. RAM is where the CPU holds memory so that it can process it. Some of this memory is transferred to the L1 cache so that it can be readily available on the processor. RAM is usually in sizes of 4, 8, 16, and 32 gigabytes. A hard drive is your long-term memory, and RAM is your short-term memory. Why? Because if you reboot the computer, what's saved on the hard drive is always there. What's in RAM is cleared out. So you probably already know that your hard drive is a lot bigger than the amount of memory that your RAM could hold. So how do all of these computer programs and files that are megabytes and gigabytes in size operate on your computer? Well, first of all, your operating system will partition off a slice of your RAM just to hold the base and core operating system. This is so it can properly function at all times. Only data that is active is put in RAM. The rest of it is just stayed on hard drive in stasis before so that it can be used at a later time. Well, what happens if the RAM gets full or there's not enough memory in the RAM to hold what you requested? Then the computer takes a slice of the hard drive, indexes it, and uses it as virtual memory. It is quickly cached, and the computer knows exactly where it is. However, moving the same data from RAM to virtual memory and back continuously is called thrashing. This is when your computer gets slow. Your computer has a lot it's doing. It's trying to make sense of all the data because it has too many processes running or the files are too big. This memory also does not persist after reboots. So, how are all these computer components connected? Well, there's this thing called a bus. Maybe not a school bus, but that's what we call it, is a bus. The bus is like the central nervous system. It connects all the computers together, and the CPU sends instructions or nerve impulses to the RAM, the video cards, sound card, hard drive, and network adapter, among all the infinite number of peripherals that are out on the market that the computer could use. So where exactly is the bus? Well, it's really not straightforward where the bus is. However, all of these components are connected to the bus and allow you, the user, to interact with them through the video monitor. So if everything is connected to the bus all at the same time, how does the CPU know which device to communicate with? Well, like any good bus, you need a driver. Drivers bridge the gap between hardware and software. There's an old saying in computer science: hardware is easy, software is hard. Means software can do a lot of things, but if it can't interact with the hardware, then it becomes nearly impossible. It, Drivers provide the interfaces for the software. It contains the instructions on how to communicate. Drivers are like the nerve pulses that go from the brain through the central nervous system to the individual peripherals. It allows the brain to carry out instructions and send data to different parts of the computer. So, in summary, the CPU is the logical part of our brain. The hard drive is our long-term memory. RAM is our short-term memory. The bus is the central nervous system that connects everything together. And, and a driver is like a nerve impulse. It allows the communication between the brain and the different components. Please send all your questions via email, and I will reply to the entire class if need be. Responses should be printed out and placed in your notebook. Thank you.